Okay, so if you're working on the investigation of relationships between two categorical variables, you've got a couple of tools available to you, but there are going to be predominantly frequency tables, percentage frequency tables, and segmented bar charts. So again, the text is already here for you, so you can just pause this and copy it down if you want, and then unpause it when you're ready. Your basic two-way frequency table looks like this. And in the columns, you have one set of variables, and in the rows, you have a different set of variables. It's really important that we always have the explanatory variable in the columns and the response variable in the rows. What we're trying to do is trying to figure out if the explanatory variable impacts or creates a change in the response variable. So it's really important to get it right way around all the time. So in the previous video, we talked about whether or not there was a relationship between, say, the kind of compost you use and the height of the plants. Well, the compost in that case was the explanatory variable, so our compost types A, B, and C would be up the top, and for example, our plant types, tomatoes or whatever, would be the response variable. We use these tables to establish if there's an association between two variables, such as, does your voting preference depend on your sex? And so our job is to fill these tables in. So here's a two-way frequency table. Here's an example of one. You might choose to do this on your own, or you might choose to follow me. It's up to you. It's important when we're doing totals, we do totals down, totals right. So we do totals for the explanatory variable, and we do totals for the response variables. If you're confident with this, you can just pause it, fill it in, and then unpause it to see if you get it right. If you're not confident, you can follow with me. So it's up to you. You can either pause, do it yourself, and check your answers, or follow along with me. So they go to a local shopping centre, and they survey 34 females and 23 males, and ask which of the two major political parties they preferred, and they tell us that 18 females and 12 males preferred Labour. So what we can say is that if they surveyed 34 females, that's going to go down here in this bottom box, 34. And if they surveyed 23 males, that's got to go down here in the bottom box for total. Now the table is missing this word total down here. It also tells us that 18 females preferred Labour. So we're going to, in Labour for females, we put 18. And 12 males rather, preferred Labour. So 12 there. So we know that the totals go down. So if we've got 18 females here, and we need to have a total of 34, that means that we're missing 16. And if we've got 12 males there, and we need to have a total of 23, it means that we're missing 11. We also total right. So if we've got a total of 34 females and 23 males, that means we have to have a total of 57 participants. And we're going to total right for Labour and Liberal as well. So 18 and 12 is going to give us 30. And 16 and 11 is going to give us 27. These numbers should all agree. 30, 27, 57. 34, 23, 57. There's your two-way table. At the moment, it's not that helpful because the numbers of males and females is slightly different, and so it's difficult to tell whether or not males or females actually had a tendency to vote for Labour or Liberal. So the second part is a percentage two-way frequency table. So we're going to be converting a two-way frequency table to a percentage two-way frequency table. Again, you could pause this in and write it down before we continue, or you can follow along as I go. It's really important when you're doing a percentage two-way table, because we're trying to determine if males and females actually has an association with Labour and Liberal, i.e., does your sex actually fairly predict or give us a good chance to predict your voting preference? We only percentage the columns separately, and we only percentage down. You only need to calculate percentages for EV. So when you look at your table, you notice that last column is gone. We're only working down. And that means when you're calculating for females, you're actually calculating 18 out of 34. That's what's going to go in here. 18 out of 34, because we only want to know the percentage of females who voted for Labour. 18 out of 34 is what's going to go in the first one. 16 out of 34 is what's going to go in the second one. And then, like you did with frequency tables and percentage frequency tables way back in chapter 1 and 2, we add those up. We don't assume that it goes to 100. We do the same thing for males. So, pause video, do it for yourself, and come back and see if you got it right. Okay, so here's my completed frequency table. So I did 18 over 34 divided by 100. This time I rounded to one decimal place. I got 52.9%, and then 47.1, 52.2, 47.8%. In the end, what you need to do is you need to be able to provide an analysis of whether or not these two things are related. So, in a sense, can we predict your voting preference based on your sex? Can your sex predict your voting preference? Can I walk up to a person and say, if they're male or female, does that make them more or less likely to vote for someone? In this case, because those numbers are the same or almost the same, they're very close to each other, no, there is not an association. So here's my report. The investigation into voting preferences and sex indicates there is no association between the two, as similar voting rates for Labour exist in males and females, 52.2 and 52.9%. I could, if I wanted to, add another sentence. Similarly, there are similar voting rates for Liberal, 47.8, 47.1. In a case where there's only two options, Labour or Liberal, saying that they're almost the same in one means that they're almost the same in the other. So, segmented bar charts. Sometimes you are just given a segmented bar chart like this one here, and you're asked to decide whether or not there is an association between these two things. On the bottom, we've always got EV. On the categories up here, or the styles, you've always got RV. So these are always RV in your key in your legend. Okay. Remember, so this is what we're trying to use to predict those things there. Quick look at the graph and decide for yourself. Is it fair to say that your attitude towards gun control is associated with or can be predicted from your sex? Is there a significant enough difference between the heights of these bars for and against for males and females to say that yes, there actually is some correlation between these two? And in fact, in this case, there is. There is an association between sex and attitudes towards gun control, as more females than males were for gun control. 71.4% females for gun control up here. Only 55.2%. You've got 16.2% difference. And less females against gun control. There's only 28.6% of females against gun control, whereas in this study, there's 44.8% of males against gun control. It doesn't mean that that's true of all people, just in this particular study. Here's another example. Have a look at this. Is it fair to say that your smoking status can be determined or predicted from your education level? Or, another way of saying it, can your education level tell us whether or not you were a smoker, past smoker, or never smoked? And if you have a look at this here percentage bar chart, you can see that the number of smokers, so here's RV and here's EV, the percentage of smokers based on your highest level of education from year 9 onwards declines towards university. So that number's getting smaller every time. 33, 31, 26, 18. So the higher the education level, the less likely you are to be a smoker. And similarly, the higher the education level, the more likely you are to have never smoked. As you see, this blue bar here keeps getting bigger each time. So there is an association between these two things. And here's what you could say. There is an association between the level of education and smoking status, with the percentage of smokers reducing as education level increases, 33.9% of Year 9 educated students, but only 18.1% of university educated students. Notice that I'm quoting relevant statistics as I go, always important. An associated increase is seen in the proportion of people who have never smoked, from 30.0% in Year 9 and 53.6% university. Now, just to be clear, this isn't saying that 33% of Year 9 students smoked or currently smoke. It's saying that 33.9% of people who they surveyed who only achieved a Year 9 education as the highest level are current smokers. Last one. I'm going to let you have a go at this one. 67 primary and 47 secondary school students were asked about attitude to the number of school holidays which should be given. They were asked whether there should be fewer or same number or more school holidays, blah, 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 blah. Present this data in percentage form in a two-way frequency table. You'll probably need to do a regular two-way frequency table first before a percentage frequency table, and then a segmented bar chart. When you do your segmented bar chart, what you should end up with is two different bars, one for primary, one for secondary, and they'll have different stacks on them, whatever it looks like. Up the side, you've got percentage, and make sure you have a key when you do it as well. Okay, so first things first, do a two-way frequency table just to get your information sorted. Then do a two-way percentage frequency table. Then do a stacked bar chart, one for each of primary and secondary. Pause the video, see how you go. Do it in pencil, just in case you make a mistake. And then when you're done, unpause it and come back and see how I did it. Okay, so hopefully you had a go at that yourself. And here's a look at what I did. So I started by saying 67 primary. So I put that in my total there, 67. And 47 secondary school students. So I put them up there in my totals. They're asked about their attitude to the number of school holidays which should be given. Fewer, same, or more. 5 primary students said they wanted fewer. 2 secondary wanted more. Here's my 2. 29 for the same for primary. 9 for the same for high school, secondary school. And then what I did was I went, well, 5 and 29 and something have to equal 67, because I know that I definitely have 67. So I did 67 minus 29 and 5 gave me 33, and I did the same over here. 47 minus 9 and minus 2 gave me 36. I totaled to the right, so 5 plus 2 is 7. 29 plus 9 is 38. 33, 36 is 69. Then I checked. I added this way, 7, 38, and 69, and I added this way, and they both agreed to be 114. That's a nice little check for me to do to make sure it's all done properly. Then I did 5 out of 67, and I put that here as my fewer. And then I did 29 out of 67, and that was for the same. 33 out of 67, that was for more. Added those up, and as it turns out, when I rounded to one decimal place, slightly out, so I got 100.1, and that's okay. Then I've got, same here, 2 out of 47, gave me 4.3. Then I did 9 out of 47, and that gave me 19.1. And then I did 36 out of 47, that gave me 76.6. Then I added those up, and it came to 100. So then I made myself a segmented bar chart. One on the left for primary school, one on the right for secondary school. I put a title at the top, holiday preferences. On the left, I got my scale from 0 to 100 for percents, marking in dashes as I go, and I only wrote in 50 and 100 because you can see that the dashes mean tens. Primary and secondary, because it's categorical data, they don't need to touch, so there's a nice gap in the middle here, which is good. I drew in my lines. These numbers here, 50.8 and 100.1, they come from this percentage table up here. But because it's a stacked bar chart, I have to go from 7.5, which is this number up here. I have to go up a further 43.3. So 43.3 plus 7.5 was 50.8, and 50.8 plus a further 49.3 is 100.1. So I labeled these as where the lines are, not how much there was in that section. And then I did the same for secondary school students. Here's my 4.3 starting there. And then 4.3 plus 9.1 gives me 23.4. And then 4.3 plus 9.1 plus 76.6 happens to be 100. It's my last line there. On my right here, you see that I have a key. More, same, less. It's really nice to have this key in the same order as the stacks so that it doesn't confuse the people who are watching or who are looking at your work. You could then go on to make a report. Well, is it fair to say that preferences for holidays depends on what level of schooling you're in? Secondary school or primary school? And in fact, in this case, yes, there is. Because there's a significantly higher proportion of people who want more holidays who go to secondary school than there are in primary school. 76.6% of secondary school students want more holidays. Only 49.3% of students in primary school want more holidays. And at the other end, similar deal. Only 19.1% of secondary school students are happy with the number of holidays they have. 43.3% of primary school students are happy.